Okay, so let's continue our discussion on alkanes. So last time we were able to discuss our long chain alkanes, just the zigzag things, no? Pero one version of alkanes, another version or isomer of it is the alkanes that form rings, no? We call them the cycloalkanes, no? So what are cycloalkanes? These are alkanes that form rings, no? That happens when your carbon atom joins, no? So kapag nag-circular formation yung carbon atoms, they form rings, no? So our cycloalkanes, there are hydrocarbons, no? In which all of the carbons are saturated. That means lahat ng carbons mo may mga hydrogen. So you will not expect double bonds here. So basically alkane pa rin yan, no? So yan, so ito yung mga representation ng ating some of the cycloalkanes that we have, no? So for example, we have cyclobutane. So what is a cyclobutane? From the word itself, butane, meaning four carbons. However, it is in a ring system. So, cyclobutane yung tawag sa kanila. Again, pag butane, apat na carbons. However, the term cyclo tells us na yung carbons ay linked all together, no? So, ito yung itsura niyan, no? So, this is our condensed structural formula. This is our line angle formula. So basically, gumagawa lang tayo dito ng basic shapes, no? Mga square, pentagon, hexagon. Actually, may triangle din na ganito, no? That's for cyclopropane. No. So for cyclopropane, that's CH2, CH2, and CH2. So nakapa-triangle yan. Okay? So anyway, so let's continue our discussion here. This is your ring, no? This is your cyclic alkane. Kung mapapansin nyo, this carbon is bonded to two atoms already, to two other carbon atoms. That leaves this carbon to accommodate two more hydrogens, no? So kaya CH2 yung formula dito. Same here. So may dalawang bond na dyan, apat yung pwede. So we can add two more hydrogens that will give us the formula for this carbon, CH2. No? Same is true for this one and that one. Okay? So, mapapansin ninyo, if your cycloalkane do not have any substituent, meaning walang mga nakatusok dyan, the formula for each vertices, for each point of your polygon is CH2, no? So, CH2, 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 CH2 yan. No? For cyclopentane, that is a cyclic compound with pent 5 carbons. No? So ito yung 5 carbons. 1, 2, 3, 4, 5. So yun yung 5 carbons done. And as usual, this carbon has 2 bonds already. This carbon also have 2 bonds already. So that means each carbon will be able to accommodate 2 more hydrogens. So the formula for each vertices of our shapes, no, of our polygon is CH2. No? And for cyclohexane, what we have here is ito, meron tayong hexagon because six-membered ang ring natin. No? So basically, parang gumagawa lang tayo ng polygons, no? Just like what we do when we were in kindergarten. No? So yun. This time nga lang, yung ating polygons, may meaning siyang carbons. No? So basically, parang nag-aaral lang ulit tayo ng ginagawa natin ng bata pa tayo. No? So for each vertices of the polygon, you have your CH2s there, provided that there are no substituents. No? Okay, so the number of carbons for our cycloalkanes, the ring size can vary from 3 to over 30 carbon atoms. However, the common cycloalkane version is the 5-membered ring or the 6-membered ring, no? The cyclopentane and the cyclohexane. So sila yung common, while the other are not that much common. Okay? So yan. When we are going to name our cycloalkane, we still follow the same rules as the alkanes, no? Same pa rin like the alkanes. However, um, we have to affix the prefix cyclo dun sa prefix ng number of carbons. For example, here you have how many carbons in your ring. So, ganun yung unang gagawin niya. Hanapin niyo yung ring. Ito yung ring. Okay? So, ilang carbon meron dyan? 1, 2, 3, 4, 5. So, you have 5 carbons there. 5 means pent, no? And since this is a ring, naka-ring yan, so you have to use the word cyclo, the prefix cyclo, pentane, no? So, that means this pentane, itong 5 carbons na yan ay naka-ring. So, cyclopentane. So, same is true for this one. We have here the 6-membered ring. 1, 2, 3, 4, 5, 6. So, itong ating hexagon, may 6 carbons at each vertices. So, we call it cyclohexane. So, hexane, 6 na carbons. Cyclo, meaning the carbons are linked to form a ring. No? So, yan. So, that's the first way to name our cycloalkanes. No? And usually, for our course, now for the simplicity purposes, our ring chain is our parent chain. So, ito na yung ating mga parent chain na for simplicity sa ngayon lang. Okay? So, yun lang. What else? If we only have one substituent on our ring, there's no need to give it a location number. We do not have to write a locant for it. No? Compare that to your alkanes. No? For example, ilagay mo dyan yung iyong methyl group. You have to name this 2-methyl pentane. If you place your methyl group here, you have to name it 3-methyl pentane. For cyclic compounds, if you only have one substituent, giving the locant number for each substituent, for the substituent, no, is not necessary. No? Kasi elsewhere you place it on the ring, same pa rin yung kanyang locant number. For example, this is isopropyl pentane. No? So if you're still familiar, sabi ko last time, if may letter V attached to the parent chain, you call it isopropyl. No? So yan. So yan yung ating isopropyl that is attached to your cyclopentane. No? So if you're going to give this a number, I will give this number 1. Una yan. So, yan. So always number 1 yung locant niya. Regardless kung saan man siya nakakabit. No? Kasi left to right or right to left, you will still end up with the lowest number being 1. No? So magiging 1 talaga yan parate. So no need na to assign the substituent number 1 if iisa lang yung ating substituent na. So, huwag mo nalagyan ng 1. Matic na yon. Kahit saan mo yan ilagay, yung locant number niyan ay 1 pa rin. Okay? So, yan. So, we do not have to give it a number pag isa lang siya. However, if we have multiple substituents, such as 2 and above, then we have to assign numbers. No? So, how do we assign substituent numbers for cyclic compounds, no? So ganito, when we are assigning numbers, we give the lowest number, which is 1, to the name of the substituent which comes first alphabetically. Kung sino yung mauuna by alphabet, siya yung bibigyan mo ng 1. Then the rest is yung basta yung lowest combination na lang, no? Yung mga nasa tabi niya, bigyan mo na lang ng lowest number, depending on the on how you number the carbons in your ring. Mamaya mag-example tayo dyan, no? For example, we have this one. We have this substituent. This is the paan ng manok na tinatawag ko last time. I call that tert butyl, no? So yan, so that's your tert butyl and this is your CH3 which is methyl, no? So if we are going to compare the tert butyl and the methyl, sino yung mauna alphabetically? So it's not the methyl, it's the tert butyl. Again, if we have a dashed prefix to your name, hindi mo isasama yung tert. No? Yung sec, then hindi rin siya kasama. ano yung mga pwedeng kasama? Yung iso lang and then yung name lang ng substituent, no? So, yung mga di, tri, tetra, tert, yung sec, hindi sila kasama sa pag-alphabetize, no? Itong mga butyl yung gagamitin natin. So, yung methyl, letter M yung gagamitin natin basis, no? For giving it priority. So, mapapansin nyo, butyl is letter B, M, yung methyl. So, butyl will come first. So, I have to give it the substituent number 1, no? So, yan. So, siya yung bibigyan ko ng number 1 kasi siya yung mauuna alphabetically. Then, the rest is just, counting clockwise or counterclockwise, no? So, mapapansin natin, if we do it clockwise or counterclockwise, the methyl substituent will have a locant 4, no? Kahit clockwise yan or counterclockwise, no? So, one good example naman is ganito pa. Bigyan ko kayo ng isang example. What if your methyl substituent is here? Wala dun sa dulo. So, ganun pa rin na. Tert butyl pa rin to. Ito ay methyl. This is still cyclohexane. However, ano mangyayari? Your tert butyl will still have a substituent number 1. Pero yung iyong methyl, ano kaya magiging number niya? So if we assign carbons, carbon number clockwise, no? So this is the first carbon, this will be the second, and this will be the third carbon. If we assign numbers counterclockwise, so this will be the second carbon, this will be the third, the fourth, and the fifth, no? So ngayon, we have a dilemma. So sino sa dalawa ang pipiliin? Is it the carbon 3 or carbon number 5? Pag ganyan na yung case, always the lowest combination pa rin, ha? Lowest number pa rin yung gagamitin mo. Ang alkane lang din talaga, no? Pero this time, we are counting clockwise or counterclockwise instead of left to right and right to left. Okay? So, ganun lang. So, pag clockwise, the carbon number is 3. Kapag counterclockwise, the carbon number is 5. So, we will choose 3 over 5. So, the name of this compound will be 1/3 butyl 3-methyl cyclohexane. Okay? So, ganun yung kanya magiging name. So, same lang as alkanes, no? Kung mapapansin nyo. Same lang talaga yan. So, ngayon, let's practice to name some alkanes. So, we have the 3 alkanes in your worksheet. So, sagutan natin. So, for letter D, anong meron dyan? So, tingin ka sa ring mo. Anong shape ng yan? Anong shape yan? That is a hexagon, no? Okay, so ilang carbon meron dyan? 1, 2, 3, 4, 5, 6. So, 6. So, that will be your parent chain. So, since it has 6 carbons, we will name it cyclohexane. Malakas pa rin hangin dito. Okay? So, ang name niyan ay cyclohexane. Cyclo kasi naka-ring, hexane kasi 6 carbons yung nasa ring. Okay? So, cyclohexane. Then now, check natin yung substituents natin. So, ano yung mga substituents natin? We have a methyl. We have methyl group there. And then we have letter V uli, no? So, ano yung letter V? Isopropyl. Okay? So, just in case na nakalimutan nyo yung mga substituent name, punta lang kayo dito. Ayan. Okay? So, mapapansin natin, just what I told you last time, pag isopropyl, yan yung letter V connected to your parent, no? So, that is the isopropyl, yung letter V connected to the parent. Isopropyl, no? Okay? So, ganun lang. Pag di pa rin kabisado, take time to memorize that, no? So, yun. So, this is our methyl, this is our isopropyl substituent. So, na-name na natin yung substituent. Now, we have to arrange them alphabetically. So, who will come first? Is it the methyl or the iso? Ang iso ay kasama sa pag-alphabetize. No? Ano yung hindi kasama sa pag-alphabetize? Greek prefixes, yung di, tri, tetra, hindi kasama yon. Yung sec and tert, hindi rin sila kasama. Pero yung iso, kasama yan. No? Okay, so kasama sa alphabetization, yung iso. So, sino mauna? Is it the I or the M? A, B, C, D, F, G, H, I. So, I muna. J, K, L. So, yan. L, M sunod. L, M, N, O, P. No? So, I muna bago yung M. So, I will give my isopropyl the locant number 1. Ganun ha. Alamin mo muna yung alphabetical arrangement nila. Then, automatically, bigyan mo ng 1 yung mauuna by alphabet. No? Then, ano susunod natin gagawin? You can now continue numbering your ring, no? Clockwise or counterclockwise, no? So, yung green, yung clockwise ko. Okay, so ito yung clockwise ko, yung green. Ang counterclockwise ko ay yung, let's say, yung black, no? Okay. So, yan. So, this is yung green, yung aking clockwise counting. So, 2, 3, 4, 5, 6. Yung black yung aking counterclockwise na counting. 2, 3, 4, 5, 6. Okay. So, looking at this methyl substituent, it can either have a locant of 2 or 6. Which is better? Yung 2 or yung 6? Edi, yung lowest number, no? So, we will choose 2 over 6 because lowest yung substituent number na yan. Okay? So, the name will be 2-methyl, then 1-isopropyl na. So, ganun lang. So, same lang ng ginagawa natin with alkanes, no? May onting spice lang. Then, what's next? Okay, so we have to write the complete name. So we have to combine all those names ng substituent and the parent to create the complete name of our cycloalkane. No? So ano yung kanya magiging complete name? So pag ina-arrange ang substituents, alphabetically yan. No? So we begin with 1-isopropyl followed by 2-methyl. Then, lastly, yung cyclohexane. Okay, so alphabetical yung arrangement sa final name natin. Okay, so 1-isopropyl, 2-methyl cyclohexane. Okay, again, I would like to reiterate, if number and letter ang magkatabi, you have to place dashes. No? Propyl dash 2 dash methyl. Hindi pwedeng walang dash na yung kasi yung rule ng IUPAC. If parehas number ang magkatabi, kailangan ng comma. Pero if parehas letter ang magkatabi such as methyl cyclohexane, walang spaces na. So, why do I reiterate that? Kasi pagdating sa quiz ninyo, most of the items will be free response type, no? So, kaya magta-type ng sagot. Kailangan alam niyo kung paano ilagay yung mismong name. As much as possible, i-lowercase nyo na lahat, no? Okay, kahit di nyo na i-uppercase yung unang letter, okay lang. Lowercase na lang lahat. And yung correct dashes, correct comma, and walang spaces. Okay? So, yan lang. So, that's how we name our compound for letter C, no? So, its name will be 1-isopropyl 2-methyl cyclohexane. Okay. So, let's try letter E. So, tapos na tayo kay letter D. Screenshot niyo muna, no? Kung gusto niyo i-screenshot. Okay. So, let's do letter E naman, no? Gawin naman natin si letter D pala. Maski ako nalilito ako sa... hindi, letter D nga to. Ito, letter E. Kasi F yan. Okay. Sige. So, gawin na natin si letter E. Okay, so for let's find the number of carbons in your ring. So for this case, ilang carbon meron sa ring natin? 1, 2, 3, 4, 5. So we have 5 carbons in our ring. So ang pangalan niya would be cyclopentane. Okay, cyclo kasi naka-ring, pentane because we have 5 carbons here, no? So cyclopentane. So pentagon yung shape niya. Okay? So ganun lang. Then ilang substituent meron tayo dito sa ating cyclopentane? So we have one substituent only. Ito yung substituent. Ano kaya pangalan niyan? So ang pangalan niyan ay isobutyl. Okay, so the name of the substituent is isobutyl. Paano nakuha yon? Kasi given yun sa PowerPoint last time. Okay? Pag di pa kabisado, pwede tumingin uli dito. So kapag isobutyl, ano yung itsura? For example, this is your parent. No? You have a CH2, CH, then dalawang CH3. CH2, CH, dalawang CH3. Yan yung iyong isobutyl. Okay? So, you really have to memorize all of them, no? So, yan. So, ito yung CH2, ito yung CH, dalawang CH3. So, basically, isobutyl siya. Okay, so since we only have one substituent, do we have to assign a locant number? Do we have to assign a locant? Hindi na. Kasi isa lang yan eh. Regardless on where you place your isobutyl, pwedeng andyan, pwedeng nandito, pwedeng nandun, dito or doon, its locant number will always be 1. So, hindi mo na kailangan i-assign yung number 1 kasi automatically, you will assign it the substituent number 1. Okay? So, ano yung name niya? So, the complete name will be isobutyl cyclopentane. So, wala na tayong locant number because we only have one substituent. Naantok pa ako eh. Alam ko kayo rin, lamig yan, no? So, anyway, so that is isobutyl cyclopentane. Okay? Gawin naman natin to. Itong letter F. Yan. So, tignan nyo yung ano nyo, ring. Ilang carbons meron sa ring? We have 6 carbons in our ring. There's 1, 2, 3, 4, 5, 6. So, 6 carbons. So, ang pangalan niya ay cyclohexane. Hexane kasi 6 na carbon. Cyclo kasi naka-ring. No? Actually, you can infer an idea kung ano pwede maging name niya. Kapag hexagon siya, cyclohexane, andun yung hex, no? Kapag pentagon yan, cyclopentane, no? Pent for pentagon and pentane, no? Kapag yan ay square, cyclobutane. Kapag yan ay triangle, cyclopropane. Paano naman kapag 8 carbons na rin, edi cyclooctane, no? So, ganun lang ha. So, yun. Associate the shapes of your polygons with the names na lang, no? So, ganun. So, we have hexagon here. So, automatically, cyclohexane ang kanyang pangalan. How about the substituents, no? So, we have 3 substituents, 2 of which are the same. So, ano yung dalawang parehas na substituent? Yung methyl. You have a CH3 here, another CH3 there. So since dalawa yung ating methyl, papangalanan natin yung dimethyl. Dimethyl, dalawang methyl. Question, Do I have to include yung di when I am going to arrange them alphabetically mamaya? Hindi na. Hindi po necessary na yung D ay isama mo sa alphabetization. Hindi kasi talaga siya kasama. Yung methyl yung susundin, not the di. Hindi yung di. Okay, so we have two methyls. Dimethyl ang kanyang pangalan. And then we have this one. Ano pangalan ng substituent na to? This is carbon 1, carbon 2, ethyl. Dalawang carbon. No? Okay, so ayan. So we have dimethyl and ethyl substituents. No? Ngayon, we have to alphabetize them so we can check kung sino yung bibigyan natin ng 1. So sino yung bibigyan natin ng number 1. So sino mauna, is that the ethyl or the dimethyl? That would be ethyl. Kasi again, yung dimethyl, yung M lang yung titignan. So sino mauna alphabetically? Syempre, letter E muna before the letter M. So we will assign ethyl a locant number of 1. So 1 ethyl yan. So after assigning the locant number 1 for ethyl, we can continue numbering our carbons clockwise and counterclockwise. No? So clockwise yung green, 2, 3, 4, 5, 6. Yung black naman will be the counterclockwise, 2, 3, 4, 5, 6. No? Okay, so as you can see, for our dimethyl, we can either have a locant number of 2, 4, or we can also have 4, 6. No? So 2, 4 if we count the carbon atoms clockwise, 4, 6 if we count the carbon atoms counterclockwise. Sino yung better? Is it the 2, 4 or the 4, 6? Anong sagot? E di syempre, yung 2, 4. So, hindi natin gagamitin yung 4, 6 because, again, always the lowest combination ang gagamitin. Okay? So, ganun lang. So, same lang like alkane, di ba? So, ano pangalan niya? Yung complete name niya. So, unahin natin yung ethyl. So, that will be 1 ethyl dash. Susunod na substituent, 2, 4 dimethyl. Then, cyclohexane. So, that will be its complete name na. So, hindi siya si Gemerlin. Ang pangalan niya ay 1-ethyl-2, 4-dimethyl cyclohexane. Okay, so alphabetical pa rin yung arrangement. No? Ethyl muna before the dimethyl. Ganun lang. Ayan. Yan na yun. Okay, so ganun lang yung naming. So that's the same as your alkanes lang. Okay, so we're done with the nomenclature of our cycloalkanes, no? Basic lang yan. Ito yung isang question ng bata sa akin. Sir, pwede po ba yung cycloalkane ko ay maging substituent? Hindi siya yung parent, siya yung magiging substituent. The answer is yes. Pwede siya maging substituent. Kailan siya magiging substituent? Kapag yung alkyl chain nyo, yung inyong substituent ay mas mahaba yung carbons kaysa sa cyclic compounds. No? Although we will not cover that anymore. Kasi sabi ko nga, sisimplihan lang natin tong org chem. Para masaya yung buhay. Tsaka we have limited time na eh. No? We have lots of holidays this coming month. Then December, magpapasko na. So, kailangan na natin matapos yung class na to. So, ganito lang muna tayo ka-simple ha. So, okay na yan. So, for the simplicity, yung ating cyclic compounds ay ang parent. However, yes, they can also be a substituent. So if you want to see the in-depth discussion on this, punta kayo sa YouTube channel natin, yung OrgChem Chapter 5 na Chapter 5 'yan. Yes. OrgChem Chapter 5, hanapin niyo 'yon. Panoorin niyo yung 6-hour video na 'yon, no? Day 1 and day 2. So, doon yung malalaman ng in-depth yung OrgChem, no? Anyway, so punta naman tayo dito sa conformation of alkanes, no? So when we say conformation, this is the spatial arrangement of your carbons in the molecule, no? So remember, your carbons are in a tetrahedral shape, no? So yung tetrahedral shape, pwedeng gumalaw-galaw yan, no? Ang tawag natin sa arrangement ng ating molecules in a three-dimensional space, we call them the conformation. So let's take, for example, the butane. So we have here the butane. The typical structure of your butane is this one. Naka-alternating, naka-zigzag sila. Naka-zigzag yan. So this is your common structure for cyclobutane. Ayan yung ganito, yung drawing. Okay? However, by the way, bago ako mag-however, mapapansin nyo, yung carbons natin naka-tetrahedral pa rin yan, ha? Tetrahedral, 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 tetrahedral. Tapos naka-zigzag sila. Okay, so this is one way to draw your tawag dito, your butane, no? However, kung mapapansin nyo, yan ay single bond, no? So naka-single bond yung mga atoms dyan. Ano pwede mangyari kapag single bond yung bonds ng ating atoms? The bond can rotate. Pwede umikot yung bond. Kasi single bond lang yan. Imagine niyo na lang yung pencil nyo. So yung dalawang kamay mo yung carbon. So if you rotate your hands around the pencil, mapansin nyo, the atom can rotate. So pwede umikot itong carbons na to. So ganun lang yung logic dyan. Kuha kayo ng pencil or ball pen, yung dalawang kamay nyo, hawakan nyo yung magkabilang dulo, then i-rotate nyo yung isang kamay nyo. So since pwede yan mag-rotate, then it is true that if you have a single bond, the atoms can rotate, no? Kailan po mawawala yung rotation, no? The rotation can be restricted by double bonds, no? So for example, I have here a marker and my pencil. So pag double bond yan, if I try to rotate my hand, mapuputol yung aking pencil, which is ayaw ko gawin. Okay, masisira yung aking pencil. Wala akong pansulat sa iPad, no? So kapag may double bond tayo or may triple bond, you can no longer rotate the bond, no? So yan, so I have 2 markers, 1 pencil. So triple bond yan. Hindi ko na pwede ma-rotate yung aking carbon atom. So if you have a single bond, then your carbon can rotate, no? Otherwise, hindi na pwede. Okay? So ganun yung nangyayari dito. So what happens here is that, for example, itong carbon group na to, i-rotate natin, pwede siya umikot, no? So instead na ganito yung drawing niyan, ang magiging itsura ng ating molecule ay nakapaganyan, no? Ayan. So same yan, nakapaganyan yung itsura ng molecule. So ano nangyari? Itong CH3, instead na nandito siya, dun siya napunta sa taas, no? Okay? So ganun lang yung ginawa natin dyan. Yung CH3 ay ni-rotate because it is possible. What happens here is that for every conformation, for every rotation of your carbons in your molecule, there are some consequences. Bakit may consequences? No? Kasi atoms yan, and atoms have electrons. What's the basis for the geometry of the molecule? Diba, yun yung valence shell, electron pair, repulsion theory. According to Vesper, your electrons, your atoms, no, may repel, no? Pwede silang mag-repel kapag magkakatabi sila. Magkakahiwalay sila to minimize the repulsion. Pero for example, we rotate this group, no, by 120 degrees, naging ganito na yung itsura niya. Ano mapapansin natin? that our CH3 groups here, etong CH3 at yung mga CH3 na yon, magkatapat sila. Ano meaning nun? Okay. So kapag magkatapat yung ating groups, no? For example, yung CH3 and another CH3, ano mangyayari? There will be a repulsion. Okay? Repulsion mangyayari dyan because of the crowding. Okay? Magiging crowded yung side na yon. Bakit? May CH3 dito, may CH3 din doon. So, the atoms will repel. So, due to the crowding, due to this conformation, ito ay magiging unstable. Okay? Lower yung kanyang stability. Yun, unstable siya. So basically, kapag ang iyong groups ay magkasama sa iisang side, no, in such case ganito, yan ay magiging unstable, no. So we will not observe this, no. Hindi natin ma-observe to masyado in nature, rather we will observe this one. Kung saan yung iyong groups, no, yung CH3 groups ay magkakahiwalay, no. So mas better yan, no. Mas na nga, better pa. So, better talaga siya, no? Kasi yon magkahiwalay ang iyong groups, no? So, there will be no repulsion, no? So, yan. So, this will be the better conformation instead of this one, na magkasama yung dalawang groups, no? Ang possible questions dito sa quiz ay, kunwari, may mga drawing ka ng iyong alkanes. So, which is better? Etong ganyan or etong ganito? So, syempre, piliin mo yung magkakahiwalay yung mga groups, no? Ito yung magiging sagot doon. Okay? So, ganun lang. So, anong nalaman natin dito sa conformation? That our molecules can rotate, no? And depending on the rotation, it can have a side effect, no? So, if the rotation produces a molecule in which there is crowding, no, magkakasama yung mga groups such as this one, so, unstable yung mga yon. So, they will not be found in nature that much. No? Hindi natin sila makikita in abundance. No? Ang makikita natin madalas ay yung mga magkakahiwalay. No? Okay? Such as this one. Yung less crowded. No? Okay? So, ganun lang. Marami pang versions ng conformation. No? If you want to learn more nga, punta kayo sa OrgChem Chapter 5, day 1. Nandun yun eh. Okay? So for our cyclic compounds naman, since ang focus natin ay mga cyclopentane and cyclohexane lang, since they are the common, meron din silang conformation. Na. So sabi natin, in our orgchem, yung carbon, it will follow a tetrahedral geometry kapag puro single bond yung meron siya. Na. So since tetrahedral yung shape niyan, for cyclic compounds, that tetrahedral shape must also be conserved, no? So, ibig sabihin, even that is a cyclic compounds, kailangan naka-tetrahedral shape pa rin yan. Okay. So, for cyclopentane, we have 5 carbons arranged in a tetrahedral fashion. So, ayan, naka-tetrahedral yan. Ayun, naka-tetrahedral. Ito, at ayun ay naka-tetrahedral. Ito rin naka-tetrahedral, no? So, when our carbons in our cyclic compounds are in a tetrahedral manner, then, ano meron? So, ano mangyayari? So, if our carbons in our cyclic compounds are in a tetrahedral pattern, then yun yung stable conformation niya, no? So, stable yan kasi lahat ng carbons naka-tetrahedral. This conformation of cyclopentane is called the envelope. Ang ingay ng aso. Wait lang. Kakahol-kahol yung aso. Takot naman yan sa pusa eh. So anyway. So ito yung ating cyclopentane. Kapag ang ating carbon sa ating cyclopentane ay naka-arrange in a tetrahedral manner, ang tawag sa kanya ay envelope conformation. Bakit yan naging envelope, no? Kung titignan mo yung top view ng molecule na to, etong 4 na carbons here, nakapa-square yan. Then, etong carbon sa taas, nakapa-triangle yan. Na. Bakit yan naging envelope? Kasi imagine yung envelope na naka-open. 'Di ba yung envelope ganyan yung itsura. Try mo i-close yung flap niyan. I-close mo yung flap ng envelope. Ano may yung itsura niyan? Ayan. Envelope. 'Di ba? Imaginative yung mga chemist natin. Ganun talaga. Kasi mga molecules yan, may shape yan. So, kailangan isipan mo, ano kaya pwede tawag dito? So, sabi nila, envelope daw. Okay? So, yan. Inimagine nila yan as an envelope na naka-open. Okay, ganito yung itsura niya. Okay? So, that is the conformation of your cyclopentane. This is the most stable conformation. So, does that mean na may iba pa siyang conformation? Meron po. Though we will not discuss them any longer. Kasi baka maloka na kayo. No? Kasi magulo talaga yung mga drawings dyan. Ito lang yung maayos yung drawing. No? So, okay na tayo dito. What is the most stable conformation of cyclopentane? Envelope conformation. Okay? For cyclohexanes naman, the stable conformation of our cyclohexane is the arrangement in which your carbon is tetrahedral then, no? So this is the most stable version of our cyclohexane wherein all the carbons are in a tetrahedral shape, no? So yan, tetrahedral to, ito, ayun, 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 ayun. Lahat sila ay naka-tetrahedral. So ano yung itsura niyan? So ang itsura niyan ay parang messenger icon. Punta tayo dito sa messenger. Ayun. Search na nga natin sa Google. So, parang messenger icon yung mangyayari dyan for cyclohexane. So, ito yung itsura ng carbon atoms dyan. No? Carbon to, carbon yon, carbon yon, carbon yon, carbon yon, tas carbon pa yon. No? So, we have 6 carbons arranged in a manner wherein may isa sa baba, dalawa sa taas, dalawa sa baba, isa sa taas. No? So, yan. So, parang pa-zigzag sila, although by pair of atoms. No? So, dalawang nasa taas, dalawang nasa baba. No? Na carbons. So, ganun yung nawala yung pagiging ano niya. Teka lang. So, ganun yung conformation for cyclohexanes. No? So, pa-messenger icon sila. So, ang tawag natin doon ay the chair conformation. No? So, chair conformation ang tawag sa most stable conformation of our cyclic hexane. No? So, naka-chair yan. Nakapa-zigzag. So, ito yung mga representation of our chair conformation. We can either have a skeletal model, ball and stick model, and the top view ng ball and stick model. Paano pala ito naging chair? Kasi siguro in-imagine nyo, paano yung naging chair, no? Kasi yung envelope, parang okay lang, no? Understandable naman yung envelope kasi mukha siyang envelope. Etong chair, paano yan naging chair? O ganito daw. Imagine, ito yung backrest. Tapos ito yung paanan. Tapos ikaw ito. Nakaupo ka dyan. Ayan. So, para siyang chair. Pero pangit lang yung drawing ko, no? Teka nga lang. Ang draw natin. Ayan, yung tao. Nakaupo siya. Ayan. Okay? So, para siyang chair, no? Kung hindi nyo ma-imagine, pilitin na lang natin. Ang hirap mag-drawing eh. So, ayan yung chair, ha? So, ganun yung ini-imagine nila. So, ito yung upuan. Ito yung backrest ng upuan. Ito yung sa paanan, no? So, naka-chair conformation siya. Okay? So, this is the skeletal model kung saan yung carbon atoms ay hindi pinapakita, no? Tapos yung hydrogen pinapakita. This is the ball and stick model. This is the actual representation of your molecule. So, yan. So, naka-chair conformation yan. Ayan. Ayan. So, naka-chair conformation yan. And this is the top view, no? Ito yung top view kung saan titignan mo siya from this angle. So, naka-hexane yung kanyang drawing pa rin, no? Okay. So, naka-hexane yan. Pero, naka-chair yan sa side view. Okay? So, that is the most stable conformation of our cyclohexane. Marami pang version yan. May chair, may twist, may boat, no? Hindi na natin didiscuss yung mga yan. In a chair conformation of our alkane, we have 6 CH bonds that are equatorial and 6 CH bonds that are axial. So, paano natin makita yung axial and the equatorial? So, let's have this one. Okay, so for carbon and hydrogen, if your hydrogens are pointed upwards and downwards, then they are axial. Nasa axis sila. Okay? So, ilan yung nasa upward and downward position ng ating hydrogen sa ating cyclohexane? Yan ay taas na tatlo, nakababa na tatlo pa. So, 6 yung ating axial. So, nasa axis sila. How about the equatorial? Ang equatorial naman, they are pointed on the side, no? On the side around the axis, no? So, this is the imaginary axis at which your axial hydrogens are pointed upwards and downwards. Tapos, yung mga naka-point sideways, we call them the equatorial hydrogens, no? So, yung mga naka-point sila sideways, no? Yan, nakapatagilid sila. Okay? So, for your cyclohexane in a chair conformation, you have 6 equatorial CH bonds and 6 axial CH bonds. No? So, yan. So, 6 naka-point pataas and pababa. Tapos yung 6 naka-point left and right. No? We can represent them with this structure. So, this is another skeletal structure. So, kapag axial, they are sideways. Yung bond ay nakatabingi, pagilid. However, kapag yan ay axial, straight line yan. No? Straight line yan. Pataas and pababa. No? Pero kapag yan ay, pag yan ay equatorial, naka-bend. No? So, yan. Naka-bend yung angles. Okay? So, ganun lang. So, these are the 3 axial hydrogens pointing upwards. So, sila yung tatlong yon. Highlight natin. So, sila yung pointing upwards. Ito naman yung pointing downwards. No? Then, ito yung axial, equatorial. Ayun. So, if your cyclohexane has a substituent, no, meaning may nakakabit sa iyong cyclohexane, the most stable version of it is the equatorial position of your substituent. No? So, if you have a substituent, ano yung most stable version? Yung equatorial instead of the axial. Bakit? No? So, bakit nga ba? Kasi, ito, for example, we have this. So, this is our methyl cyclohexane. This is your methyl. This is your cyclohexane. If that is pointed equatorial, no, in an equatorial position, pag nandun siya sa equatorial position, it will not interfere with the atoms of your cyclohexane. Wala siyang tatamaang atoms doon because it will occupy another region outside the molecule, no? So, ito yung occupy niya sa labas. So, ibig sabihin, hindi niya bubungguin yung mga atoms dito. Wala siyang matatamaan. Nasa gilid siya lumitaw. That's for equatorial. However, if the methyl group is in axial position, ano mapapansin natin? Ito, nasa taas yung CH3 mo. Ang mapapansin nyo, may tinatamaan siyang hydrogens. Ayun, nagitnaan niya yung dalawang hydrogens, no? So, kumbaga, there is an axial interaction. We call this the 1,3 diaxial interaction. Anyway, di nyo naman kailangan alamin yung pangalan. No? Pero yung tawag natin dyan ay 1,3. Nawala. We call that the 1,3 diaxial interaction. Ibig sabihin yon, sa 1 and 3 carbons, 1, 2, 3, 1, 2, 3, 1, 2, 3. So, nagtatamaan yung kanyang mga substituent kapag naka-axial yon. So, mapansin natin, this CH3 bumps against these 2 hydrogens here sa third carbon from here. 1, 2, 3. Ayan yung hydrogen doon. 1, 2, 3. Ito yung hydrogen na tinatamaan ng CH3. So, ano yung mangyayari? So, there is a, what's called the, anong tawag dun? Letter C. Meron tayong crowding na nangyayari. No? So, may crowding tayo na nangyayari if naka-eggshell lang iyong substituent. And because may crowding, natatamaan niya yung hydrogens. No? So, unstable yon. There is a repulsion for the molecule. No? So, whenever you have a 1,3-dieggshell interaction, meaning naka-eggshell yung isang substituent, pangit yon. No? Kasi natatamaan niya yung ibang atoms. No? So, unstable yung version ng molecule kapag ganyan. So, the more stable one is the equatorial position. Okay, that is only true kapag mono-substituted ang iyong cyclohexane, meaning isang substituent lang meron. Sir, paano kapag multiple substituent? Di na natin i-discuss yun. No? Kung gusto niyo malaman, nasa OrgChem Chapter 5, Day 2. Yun. No? Napuntahan nyo na lang yung video na yun. Kasi again, sisimplihan lang natin yung discussion dito. Okay? So, yun lang. So, ano yung nalaman natin ngayon? So, we just knew that our cyclic compounds can still conform with the tetrahedral shape. No? For cyclopentane, tetrahedral shape will be maintained if it follows an envelope conformation. So, yan yung shape ng envelope. Para siyang aso, no? Ito yung ulo, ito yung paa. Kaso dalawa yung buntot niya, no? Okay. So, yan. So, ito yung ating envelope for conformation for cyclopentane, which is the most stable conformation as the carbons are in tetrahedral geometry. For cyclohexane, the most stable version is the chair conformation, in which your carbons are in a tetrahedral manner. No? So, ano yung tsura niyan? Tingin lang kayo sa messenger nyo. Huwag nyo buksan. Baka ma-distract na kayo ng tuluyan. So, tingnan nyo lang messenger nyo. Cyclohexane to. Okay? So, in our cyclohexane, we have two types of positions. No? Pwedeng equatorial, pwedeng eggshell. Yung eggshell, they are pointing upwards and downwards as shown here sa blue H's natin. No? And yung equatorial, they are pointing sideways as indicated by pink H sa gilid. No? If you have a substituent, isang substituent lang meron, the conformation ay mas okay kapag siya ay naka-equatorial rather than eggshell. Because kapag yan ay naka-eggshell, anong interaction yung meron? 1,3-dieggshell interaction. Pangit yun kasi magbubungguan yung atoms. No? So, it is better if nakabukod siya. Mag-occupy siya ng space outside your cyclohexyl group. No? Cyclohexane group na. So, doon siya sa labas na lang lilitaw. So, that's better than this one. Okay, so also depending on the position of your substituent, whether they are on the whether they are upwards or downwards your plane, you can either have cis or trans isomerisms now. So again, what are isomers? Isomers are molecules of the same formula, but they have different characteristics. They have different properties. They have different connectivities. Now, one version of isomerism is called the cis and trans isomerism. Okay. So ano meron sa cis isomer? So cis is a Latin term, no? Meaning ng cis ay on the same side, on the same page, no? Pag trans naman, nasa opposite side, no? Ano example ng mga cis and trans sa paligid natin? Yung cisgender, transgender, no? So kapag transgender, you have this for example, you have this characteristic sa body mo pero you prefer the other gender. So nasa ibang gender yung identity mo. So trans 'yon. Nasa opposite side yung iyong identity. Pero kapag iisa yung identity mo sa physical appearance mo, then cisgender 'yon. Ano pa meron 'yan? Sa transit, no? Yung trans sa transit sa mga biyahe. Meaning nun, may dalawang opposing direction. Kaya nga transit, no? So, yung isa northbound, yung isa southbound. Yung isa eastbound, yung isa westbound. So, ganun sa biyahe, no? So, yun yung usage ng Latin terms, no? So, yung trans, opposite, parang sa kalsada lang din. Yung cis, same side, no? So, yan. So, for example, we have this cyclopentane. We have this 1,2-dimethyl cyclopentane. Bakit naging 1,2 yung pangalan niya? You have two methyl groups attached to your cyclopentane. So, cyclopentane, dalawang methyl, dimethyl. Ano yung number ng locants niyan na? Pwedeng 1 and 2. Pwedeng 1 and 2 na. So, yan. So, name niya 1,2-dimethyl cyclopentane. Pero again, depending on the position of your substituents, you can either have cis or trans isomerism. For example, if parehas silang nasa baba, that means they are on the same side. So that means they are the cis isomer. So cis isomer ito. Kasi parehas nasa side, parehas ng side yung iyong substituent. However, if one of your substituent is located on the opposite side of the plane, kunwari ito yung point of view mo, ito yung plane of symmetry mo. Nasa taas yung isa nasa baba, tawag dyan ay trans isomer. Okay? So, paano uli malalaman kapag cis? They are on the same side. Hindi naman always nakababa. No? Pwede rin parehas silang nasa taas. No? Pag nasa cis isomer yon. If they are on the opposite direction, ito nasa taas, ito nasa baba, pwede namang ito yung nasa taas, ito yung nasa baba, trans yun. Okay? So, ganun lang. So, again, kapag cis isomer, your substituents are located on the same side of the molecule. If you have a trans isomer, your substituents are located on the opposite sides of your molecule. No? Pwedeng nasa taas, nasa baba, or mixture. No? So we can present the cis and trans isomerism using wedges. No? So ano yung wedges? Parang bonds lang yan. No? Instead of drawing this one, instead of drawing 1,2-dimethyl cyclopentane as this one, instead of drawing this molecule na ganito lang, we can show na itong ating methyl groups ay naka-upwards or downwards. No? So, paano natin i-indicate yan kapag upward or downward yan? We use wedges na solid or dashed na wedges. No? So, instead of just drawing a single line dyan, ito-draw natin yung thick line na yan, parang triangle na yan. So, this is our solid wedge. Wedge. Pwede rin naman yung parang Wi-Fi symbol. So, this is our dashed. So, kumbaga, kung nagre-review na lang kayo, tignan nyo na lang cellphone nyo. Yung messenger, cyclohexane, yung Wi-Fi symbol, dashed wedge siya. No? So, ano interpretation natin sa wedge, sa solid and dashed wedges? No? Ganito. So, imagine your molecule as flat, no? Parang paper yan in front of you. So, kunwari, itong kamay ko. Ito yung cyclopentane. So, kapag yan ay naka-wedge, naka-solid wedge, this thick line, that means it is pointing towards your face. Nakaharap siya sa iyo. So, that means these CH3s are both pointing towards my face. No? So, yan yung flat na paper, yan yung screen ng monitor nyo. Yung wedges naka-point towards you. So, they are pointed on the same side, no? They are on the same side towards you. So, ibig sabihin nun, yan ay cis isomer. Pag parehas yang solid wedge, yan ay cis isomer. Paano po kapag parehas na dash? Meaning nun, yung dalawang CH3, they are pointing away from you. Nakapoint sila sa likod ng papel, nasa likod ng screen ng laptop nyo or ng cellphone nyo. So, they are still pointed on the same direction, away from you. Ayaw nila sa'yo. So, cis pa rin yun. Okay, so regardless whether that's a solid or a dashed line, as long as parehas yan, you have a cis isomer. Cis A yan, kapag naka-solid wedge, pointing towards sa'yo. Kapag yan naman ay naka-dash, that is still cis, no? Pointing away from you nga lang. O, draw ko yung dashed. Yan, parang may Wi-Fi symbol dyan. No? So, ayan. So, ito pointing towards sa iyo yan. ito pointing outwards. Hindi siya naka-point sa iyo. Okay? Nasa likod yan ng screen natin. So yan, kapag parehas solid wedge or dashed wedge, no? So yan ay cis. Paano naman kapag magkahalo? Mayroon kang solid at may dashed ka. So yun ay trans, no? One is pointing towards you, the other is pointing behind the screen, no? So ito naka-point sa harap mo, yan nakatutok yan sa face nyo. Etong CH3 naman to na naka-dash, that is pointing behind your laptops or cellphones, no? Nasa likod sila. So another version of that is ito. Okay, so ito naman yung naka-point forward, ito naman yung naka-point backward. As long as dalawa yung direction niya, pointing towards you, pointing backwards, trans yun. Pero kapag sila ng direction na pinupuntuhan, para sila na nakatutok sa iyo, so cis yan. Okay? So ganun lang. So ayan ang additional learning natin. So we can use the wedge and the dashes, no? The solid wedge and the solid dashes to indicate the 3D position of your substituents in your cyclic compounds, no? Not only in cyclic compounds, pwede rin yan sa alkanes, no? So ayan. Ayun din naman. Ayan din naman yung sinabi ko. Okay? So, pag parehas na sa likod, that is also cis. Kapag magka-opposite ng direction, trans pa rin yan. No? Okay? So, yun lang. If you want to study more of this, no, nasa chapter... Man, chapter to? Chapter 6 sa OrgChem na. Hanapin nyo sa playlist natin. OrgChem, chapter 6, day 1 and 2. 2 araw na discussion ata yun. Ata, no? So, yun lang. Okay, so we're done. Bago tayo pumunta dyan, wait lang. Bago tayo pumunta dyan sa next topic natin, mag-ano muna tayo, practice tayo. So, let's try to apply the cis and trans isomerism naman, no? So, punta tayo dito sa item number 5, question G and H, no? So sabi niyan, we have to draw the molecule trans 1,3-dimethyl cyclopentane and cis 1,2-diethyl cyclobutane. Paano natin i-draw yan? So, draw ko to. Letter G muna, syempre. So, cyclopentane ang ating parent chain. Yan yung nasa dulo. So, ano itsura ng cyclopentane? Pentagon. Oops, pangit yung pentagon. Pwede naman ako mag-insert ng shape dito, di ba? Try ko. Sticker. May sticker pala dito. Ito, shape. Wala. Okay. Yaman na. Okay. So, cyclopentane, pentagon yan. Kala ko meron eh. Yan. So, this is my cyclopentane. So, anong pa meron tayo? I have 2 methyl groups. Ang kanilang position ay 1 and 3. So, yung unang methyl group, it doesn't matter kung saan mo siya ilagay. So, it will have a substituent number 1. So, yun yung una. Then, count tayo. 2, 3. Pwede rin dito. 2, 3. So, pwede nandito yung isa pong bang methyl group. Andyan sa kabila. Pwedeng andito din. Ako, I prefer this na nandito sa gilid siya. Okay? So, yan. Pero ano yung sabi sa atin? We have a trans isomer, no? So, when they say we have trans isomer, so ano sabi natin? So, we have a trans 1,3-dimethyl cyclopentane. So, that means one of the substituent is pointing towards you, the other is pointing away from you. So, kunwari, ito, Gusto ko ito yung pointing towards us, no? So I will indicate that as a solid wedge bond, no? Ano nangyayari dito sa yan. Okay, so yan ay naka-solid wedge. So how do you draw a solid wedge? Triangle lang yan, then i-fill mo siya. Okay? So ganun. So yan. So triangle yan na nakapaganyan. Okay? So ganun lang. Paano naman yung dash? To, Wi-Fi symbol lang yan. Medyo malaki nga yung nagawa ko, pero okay lang yan. Ayan, lakihan natin. No? So meaning ito ay pointing towards us. Naka-point yan sa ating mga muka. Ito namang CH3 na to that is pointing backwards. Nasa likod siya ng screen natin. Okay? So that is the trans 1,3 dimethyl cyclopentane. Okay? We can also draw another version of it, no? Ay, galaw ng galaw yung ating yan. So ano yung isa pang version yan? Pwede naman ito yung naka-dash, ito yung naka-wedge. Okay? So ito naman yung nasa likod, ito yung nasa harap. Nasa harap, nasa likod. Trans sila. Okay? So that's how you draw trans 1,3 dimethyl cyclopentane. Next one, we have the cis 1,2 diethyl cyclobutane. Ano yung cyclobutane? 4 na carbons na naka-circle, naka-ring. So anong shape yon? Square. Rectangle yung ginawa. Draw tayo ng square. Okay na yun. So ano meron tayo dito? So this is our cyclobutane. Pakita natin yung 1,2 diethyl. So ito yung 1,2 diethyl. 1, 2. Pwede rin ito yung 1 mo, ito yung 2 mo. It doesn't matter. No? Okay. So parehas naman silang ethyl. No? So ethyl, CH2, CH3, CH2, CH3. Dalawang ethyl. So diethyl, 1, 2, cyclobutane. Okay. So yan. However, sabi dito, yan ay cis. Meaning nun, they are pointing towards you at the same time or they are pointing away from you at the same time as well. So, anong gagawin natin? So, whenever we are doing the isomerism, we only show the wedge and the dashes for one carbon atom lang. No? So, we showed the wedge and the dash sa carbon connected to your cyclic compound. Hindi sa entire molecule, no? Hindi sa entire substituent na to. Sa isang part lang, sa isang carbon-carbon bond lang, pinapakita yung wedge and dash, no? So suppose I want this to be pointing towards our face, no? Naka-point towards sa atin. So gagawin ko lang, etong bond lang na ito ang gagawin kong solid wedge. Etong bond din na ito ay this one. Hindi yun nasa dulo. Etong nakakonect sa ating cyclic compound. No? So yan, gagawin ko siyang solid wedge. Okay? So that means this carbon is pointing towards us. No? This substituent group is pointing toward us. No? Yung dalawang yan, naka-point yan sa atin. Okay? So, yan, ito yung CH2, ito yung CH3, ito yung CH2, ito yung CH3. So again, hindi necessary na sa entire molecule mo ipakita na pointing sila sa iyo. Just only the part kung saan nakakonect yan sa iyong cycloalkane. No? So dun mo lang ipapakita yung wedge and dash. Sa ibang part, hindi na. Okay na yan. No? Ganyan lang. Pwede na yan. Okay, so yan, parehas sila nakapoint sa atin. So that's the cis 1,2 diethyl cyclobutane. Then ano yung isa pang version? Pointing away from us naman. Okay, so ito yung pointing away from us. Naka-dash dyan. CH2, CH3, CH2, CH3. Again, you have to show the angle, no? na naka-bend yan. Okay? So kapag naka-dash yan, nakapag-ganon yan, okay? So may angle pa rin. Pag yan ay naka-solid, no? Naka-angle pa rin. Para ma-indicate na ito ay CH2, ayon ay CH3. Okay? So ganun lang. So yan yung mga drawing natin. These two are pointing towards our face. Ito naman, they're pointing away from the screen, no? Nasa likod sila ng nasa likod ng laptop, nasa likod ng cellphone, no? So again, ganun lang. So that's our cis and trans isomerism for cyclic compounds, no? Okay, so we're done almost, no? Malapit na tayo matapos. Punta naman tayo sa physical properties ng ating alkanes, no? So, what do we know about alkanes? So, basically, what we have here ay carbon-carbon bond and carbon-hydrogen bond, no? So, if you check the electronegativity difference of those carbon bonds, no? Carbon-carbon bond, carbon-hydrogen bond, makita nyo na ang electronegativity difference ay 0 and 0.4. 0 for carbon-carbon bond, 0.4 for carbon-hydrogen bond. Ano implication nun? That all the bonds in our alkanes are nonpolar. Nonpolar lahat ng bonds natin. So we classify our alkanes generally as nonpolar molecule. Okay? So alkanes are nonpolar because of this electronegativity difference, no? Pasok siya sa nonpolar classification, no? So that means, no, ano yung interaction na pwede gawin ng ating alkanes, no? Anong intermolecular attraction yung pwede niya gawin? Yun ay London dispersion forces or dispersion forces, no? So our alkanes cannot perform hydrogen bond. It cannot also perform dipole-dipole interaction kasi non-polar nga yung bonds natin. So ano yung natitira? London dispersion forces. What's the concept of London dispersion forces? If you could still recall sa inyong lecture. So sabi sa lecture nyo, sa London dispersion forces, tataas yan if we have more electrons na or more atoms. So if our molecule contains more carbon hydrogen atoms, then mataas ang intermolecular force. If mababa yung carbon and hydrogen atoms number, yung dami ng carbon and hydrogen atoms natin, mababa yung London dispersion forces. What is the result of having high intermolecular forces or low intermolecular forces? Okay, so ano yung implication niya? Ito, yung melting point and the boiling point, no? So the melting point and the boiling point of your alkanes may vary depending on the strength of the intermolecular force, such as the London dispersion forces. Kapag maraming atoms, mataas ang LDF. Ibig sabihin nun, mataas ang boiling point and yung melting point. No? Ibig sabihin, for your alkanes having bigger chain of carbon hydrogen atoms, no? Ibig sabihin, mas mataas ang kanyang magiging boiling point and melting point. So the smaller your alkane is, the lower the boiling point and the melting point. Hence, it will affect the appearance of your alkanes. Pwede siyang gas, pwede siyang liquid, pwede din siyang solid, no? So to give you an idea, this is the table of our unbranched alkanes, no? Basically, zigzag lang yan, na continuous. So we have methane up to decane, so carbon 1 to carbon 10. And these are the profiles, no? Melting point and the boiling point, no? So let's check on this one. So for methane, the simplest hydrocarbon, the simplest organic molecule, the melting point is negative 182 degrees Celsius and the boiling point is negative 164 degrees Celsius. So basically, at room temperature, around 25 degrees Celsius, yan ay nakagas. Gaseous phase yung methane natin. Bakit? Because at negative 164 degrees Celsius, it already evaporated. nag-evaporate na siya, naging gas na siya. Okay? Yung ethane, ganun din. At negative 88 degrees Celsius, nag-evaporate na rin yan. No? So meaning at room temperature around 25 degrees Celsius, that is already a gas. No? Example, propane, ganun din. Butane, 0 degrees Celsius. No? So yung butane natin at 0 degrees Celsius, gas na yan. No? Ayun, so gas na yan. So at 25 degrees Celsius, of course, gas talaga yan. No? Then yung pentane natin, its boiling point is 36 degrees Celsius. So ibig sabihin, at room temperature, it can exist as liquid. Tapos mag-evaporate yan upon reaching 36 degrees Celsius. So ito ay mga gas, ito ay liquids, then eventually you will have your waxes, which is an alkane group of around 20 carbons. For example, yung kandila nyo, yan, alkane yan, no? Solid yon kasi mahaba yung carbon chain doon, around 20 carbons, no? So namapansin nyo, the more carbon hydrogen atoms you have, the more longer the chain, the higher the boiling point and the melting point. So they transition from gas to liquid, solid, no? So yun yung idea. So the longer your chain, the higher the melting point, the higher the boiling point, no? One example is octane. Ito yung nasa gasolina. So mapapansin nyo, its boiling point is 126 degrees Celsius. So that means our gasoline is liquid. No? Compare mo yan sa methane, which is found in the septic tank. No? Yung mga nasa tangke ng ating mga sewage. No? Yun ay nakagas na. Hindi sila nag-exist as liquid. No? Kaya mabaho. Ayan, kumakalat yung amoy niyan. No? So yan. Ayan lang. So that's one of the physical property of your alkanes, no? So the longer the chain, the higher the melting point and the boiling point will be. Another property of alkanes has something to do with its isomers, no? So depending on the isomer, you will have different properties, no? Kasi sabi nga natin, they are different compounds, hence they must have different physical and chemical properties, no? So let's have this example. We have the boiling points of the isomeric alkanes of the formula C6H14. So the five are the ito yung ating mga isomers of this formula C6H14, no? So we have hexane, this is the longest chain, and then here we have the substituents na 2,2-dimethyl-butane. So draw natin yung comparison. Compare natin yung drawing nila, no? So hexane, ito yan. Okay, so yan yung hexane. 2,2-dimethyl-butane. So ito yan. Teka lang. Okay, so this is your hexane. Long chain yan ng carbon-hydrogen. Ito naman yung 2,2-dimethyl-butane wherein you have substituents. No? What can we observe here? Ano pa rin natin mapansin dito? That when you increase the number of substituents of your alkane, for example, ito wala siyang substituent, long chain lang yan. Ito may substituent siya. What happens to the boiling point? The boiling point decreases, no? Bakit kaya bumababa? Dahil sa branching. Ano ba nangyayari? Kasi ganito daw. When your molecule starts to be branched out, nagkakaroon siya ng substituent, bumababa ang kanyang surface area. So if that's a normal aliphatic chain, meaning straight chain lang yan, tayo lumabas ng aking markers dito sa, wait lang. Ayun. So, ibig sabihin, kapag yan ay straight chain lang, malaki yung surface area mo. Kapag yan ay may branching, smaller ang surface area. Explain natin kung bakit, no? Kasi if your molecule is unbranched, ibig sabihin, mahaba yan. So it will occupy bigger space, no? Okay? So that big space will tell you na malaki yung kanyang surface area. As ano mangyayari? So mas maraming pwedeng kabitan yung other molecules, no? Mas marami siyang pwedeng dugtungan dito. Hence, mas mataas yung magiging chances for the London dispersion, no? So an increase in the surface area, ibig sabihin nun, mas malaki yung side ng molecule that can be affected by the London dispersion forces, no? Mas maraming chances na mangyari yung London dispersion forces. Okay? So that will increase the boiling point and the melting point of your substance, no? That will increase the intermolecular forces. However, if the surface area of your molecule is small because of the lumiliit yung kanyang area occupied, no? Lumiliit yung molecule natin. Naging chunky siya, no? Lumiliit. So as your molecule becomes smaller because of the branching, bumababa ang iyong surface area. And as a result, mababa yung chances for the London dispersion forces to happen. Onti yung chances kasi maliit lang yung area na pwede dikitan ng other molecules. So sa result, bababa yung London dispersion forces, bababa yung intermolecular forces of attraction, and eventually, your boiling point and your melting point will also decrease. No? So what are the key pointers here? Number one is that as you increase the number of carbon and hydrogen atoms in your alkanes, the boiling point and melting point increases. However, with branching, no, as you increase the number of substituents of your alkanes, the lower its boiling point and melting point will be. Okay? So, yun yung kailangan nyo i-keep in mind. No? Yun lang. So, tapos na tayo sa physical. Ay, hindi pa. Ito pa, physical property of alkane. So, the solubility. So, ano meron dito sa solubility? So, sabi sa solubility, gaya ng ginagawa natin nung tayo ay elementary, like dissolves like, no? So, ano meaning nun? That means, if ang molecule mo ay polar, it will dissolve polar molecules as well. An example, yung tubig ninyo, haluan mo ng suka. Water is polar, yung OH bond ay polar. Suka is polar, may OH bond din dyan, no? So, dalawang polar molecules yon. So, kapag pinaghalo mo yon, they will mix talaga, no? However, for example, yung tubig pati yung gasolina, ano mangyayari? Maghihiwalay sila into layers, no? Yung nasa baba yung tubig, nasa taas yung gasoline. They will not mix because of this concept, like dissolves like, no? Yung ating gasolina ay non-polar, alkane yon. Ang ating tubig ay polar. So, hindi sila matchy-matchy. So, hindi sila maghahalo talaga, no? So, this is also the reason why na kapag nagkakaroon ng oil spill, yung ating oil ay nasa ibabaw. Because yung oil na yon ay punong-puno ng alkanes, no? So, the water and the oil do not mix up, no? So, what happens is the oil is being pushed, no, towards the shores, no, kung saan naging harmful siya sa local environment sa shoreline, no. Ano pa? Kapag naman may sunog involving gasoline, ano yung sabi ng mga ano, ito sa NSTP to, hindi ko na kung natuturo sa inyo, no. Mga precautionary stuff. Sabi sa amin, kapag may sunog involving gasoline, huwag mo buhusan ng tubig. Siyempre, wag mo rin dasalan, no? Gumawa ka ng action. Bakit bawal buhusan ng tubig yung gasolina kapag nasusunog? Because of the concept of solubility. According to this, like dissolves like, no? Pero kapag hindi sila like, hindi sila parehas ng polarity, hindi sila maghahalo. Kakalat lang lalo yung gasolina. Therefore, kakalat lang lalo yung apoy. Na-try nyo na yan? Ako, na-try ko na yan eh. Sinasabi ko rin sa inyo na ano lang, little experiment, no? Hindi naman sa nagsunog ako ng bagay, no? Ano lang, sa batya, bata pa ako noon eh. Ewan ko, dati mahilig pa ako talaga mag-experiment, no? So may tapos pinatakan ko ng tubig, kumalat yung apoy, no? So ito pala yung concept nun, no? So ganun. So yun lang. So ibig sabihin kapag may sunog involving gasoline, please do not do not throw water onto it, no? Kakalat 'yan kasi mag-scatter yung gasoline, no? Kasi nga hindi sila soluble sa isa't isa. What you can do is, number one, kuha kayo ng blanket, basain niyo yung blanket, tapos ipatong niyo siya sa apoy. Okay? So, hindi kakalat yung apoy doon kasi yung blanket, tatabunan niya yung entire fire. No? Ano pa? The second way to extinguish that fire is gumamit ka ng fire retardant na pwede sa non-polar molecules. No? Ano yun? Yun yung parang foam. Kung napapansin nyo yung ating mga fire truck, no? Siyempre sa Pilipinas di ko na-observe yon, sa Hollywood ko lang napapanood. So yung sa Hollywood, sa mga movies natin, yung fire truck may nilalabas silang foamy material. So yung foamy material na yon that can absorb your alkanes, no? Your gasoline para hindi na kumalat yung gasolina kapag may apoy. Or you can use fire extinguisher, no? So yun. Ayun lang. Mamaya kwento naman natin yung concept ng fire extinguisher. Okay? So, yun lang yung concept ng solubility. Like dissolves like alkane is non-polar, so it will be dissolved by non-polar solvents. No? Ibig sabihin, yung alkane mo, pwede mo yan ihalo sa another alkane. Okay? For example, yung gasoline, no? Sandamukal na alkanes yan. Yung waxes, kapag tinunaw mo, hinalo mo sa gasoline, maghahalo yon. Pero pag yung waxes nilagay mo sa tubig, mangkukulam ka na, no? Mambabarang ka na. Para ka na yung nag-aalam ng sino ng kulam, no? So, ganun. So, ganun lang yung idea. Kapag yung wax nilagay sa gasolina, hahalo yon. Pero pag sa tubig, may shape na mabubuo yun, no? Mas malalaman mo kung sino yung dahilan kung bakit nag-break kayo ng ganito, ganyan, no? So, yun yung solubility. About the density naman, your alkanes are generally lighter than water in terms of density. Ibig sabihin, mababa yung density niya compared to water. No? So, yan. So, it will float. No? So, lulutang yung iyong alkanes. For example, yung oil spill, lumulutang yung oil parate sa water, sa salt water because of that. No? Ngayon, let's proceed with the chemical reactions of our alkanes. No? So the first reaction of alkane is the oxidation reaction, or basically the combustion reaction. What happens here is that your alkanes, your CH molecules, are reacted with oxygen to form carbon dioxide and water. Familiar kayo dyan? Dapat lang. Kasi ito yung nasa chapter 4 ninyo sa lecture. Combustion reaction. Okay? So your alkanes, no, undergo combustion reaction as well. Basically, you mix your alkane with oxygen in the air to form carbon dioxide and water with energy involved. No? Okay? So yon. Dito papasok yung concept ng fire extinguisher. How come na hinihinto niya yung chemical reaction? Ano ba yung nasa loob ng fire extinguisher? Yun ay may carbon dioxide sa loob, no? So yung carbon dioxide na yun that is being blasted towards this reaction. What will happen is that pwede tayong mag-Le Chatelier principle, no? So if you have excess of this, mahihinto yung reaction towards the products, no? Mahihinto yung production ng products kang carbon dioxide. That's predicted by Le Chatelier principle. Or another explanation is that your CO2 from your fire extinguisher will remove the oxygen from the air, no? Tatanggalin niya yung oxygen sa hangin, therefore the combustion will not proceed na. So yan, so dalawang reason, Le Chatelier principle, more products than reactant, so the reaction will stop. O kaya yung oxygen mo mawawala na because it is being replaced by carbon dioxide from your fire extinguisher. Hence the reaction will not proceed. So kumbaga the oxygen becomes the limiting reagent this time. So kapag naubos na yung oxygen, tapos na yung reaction. One example would be yung kandila. Magbukas kayo ng kandila, tapos takpan nyo ng takpan nyo ng baso. What will happen is that the fire will eventually put off, no? Mamamatay na yung fire. Kasi nga nauubos na yung oxygen sa paligid, no? Naging limiting reagent yung oxygen sa air, no? Yun lang. Okay? So, yan yung unang reaction ng ating alkanes, no? The next reaction is the halogenation of your alkanes. Mamaya, daanan natin to, no? Pero kwentuhan muna natin to. So what happens here is that your alkanes, such as methane or any other alkanes, that is being reacted with your halogens, no? So, ano yung halogens nyo? Yun yung group 7 atoms ninyo. So, our halogens can exist as molecular halogens, no? So, binary molecule yon. For example, yung fluorine that can exist as F2, chlorine that can exist as Cl2, bromine can exist as Br2, no? So, yan yung ating mga halogens, no? And then when we react these halogens, F2Cl2Br2, with our methanes, or for example, any hydrocarbons, with the heat or light, especially the UV rays, um, we can create this product, no? The methyl halide, no? Or the alkyl halide. Ano yung alkyl halide? You have your alkyl group, yung mga carbon group, and your halide, yung mga Cl, F, or Br. Pwede ring I, no? Pwedeng iodine din. So we call this the alkyl halides. So you have your alkanes plus halides forming alkyl halide. Okay? So alkyl group yung carbon group, then yung halide ay yung mga Cl, F, Br. Okay? So this reaction is primarily used when forming what's called the chlorofluorocarbons, no? So ano nangyayari? For example, you have your methane. If you react that with 1 mole of chlorine gas, you will have a monosubstituted halide, no? Monosubstituted alkane. Ibig sabihin, isang Cl lang, isang H lang yung napalitan, no? So if you continue doing that, no? So pag tinuloy-tuloy mo yung reaction na yan, you provide more Cl2 or more halide, you will have a fully substituted alkane, no? We call that the CFCs, the chlorofluorocarbons. Saan ginagamit ang CFCs, no? CFCs are used as the following. They are used as heat transfer agents in refrigeration systems. Basically, sila yung tinatawag nating refrigerant, no? At the back of your refrigerator, no, meron yung refrigerant, no. Some of them are CFCs, no. So, ngayon, binabawasan nila yung use ng CFCs. Alamin natin mamaya kung bakit, no. So, yan. So, ginagamit yung CFCs na yan as refrigerant sa ating refrigerator. Ginagamit din sila as cleaners, no, solvents to clean materials, no. Ginagamit na ito actually panlinis ng laptop dati, no. And another use is the propellant for aerosol sprays such as hairspray, no? During the 1960s, maraming gumagamit ng hairspray because of fashion, no? Mapapansin niyo yung mga outfit nila, naka-elephant jeans, mga Beatles style hair look, tas naging punk, no? Yung mga buhok nakataas. Para tumaas yung buhok na yun, they have to use hairspray which is filled with CFCs, no? Yung refrigerator before, gumagamit din ng CFCs yon. And as a result, ano nangyari? Ano yung naging byproduct ng misuse ng CFCs, no? O pumunta tayo sa windy app, no? So, andun na po yung bagyo, wala na tayong class suspension talaga. Okay? So, ano magiging result ng paggamit ng maraming CFCs, no? Okay, so tignan natin yung ating atmosphere in terms of the ozone quantity. Okay, so mapapansin nyo, if the colors are blue to yellow, mataas ang ozone quantity. Ano yung effect nun? Kapag mataas yung ozone natin, ibig sabihin, medyo safe tayo from the UV rays from the sun. No? Kasi remember, our discussion on resonance, ano ginagawa ng ozone? It can absorb radicals, no, created by the UV rays, no. Pero tignan niyo yung baba, no. This is the Antarctica. So, mapapansin niyo, naging purple siya, which means mababa yung ozone concentration dito. So that means, ano nangyari? Nawala yung ozone, no. Nagkaroon tayo ng tinatawag na ozone hole, no. The ozone in the southern region, the South Pole, are actually depleted, no? Butas yan. So, anong pwede maging effect niyan? The UV rays can actually penetrate into the surface of the earth, no? Pwede siya tumagos papunta sa surface, no? Affecting humans, no? So, anong mangyayari? Kapag andun ka sa South Pole, kailangan mo gumamit ng sunscreen because the UV rays are generally higher compared to other places on Earth, such as somewhere here in the upper regions, no? Kung saan mataas ang ozone concentration. So, safe tayo dito. Kasi yun nga, the ozone can protect us from the UV rays. However, if butas yung ozone mo, yun, dire-direkta yung UV rays, no? Magkaka-cancer ka. Okay, so that's why scientists there use extra precaution, no? And protected din naman sila actually kasi they use yung gumagamit sila ng coat na makakapal, no, to protect themselves from the coldness sa paligid and the UV rays as well, no. So yan yung bad effect ng use ng CFCs, no. They penetrate, no, they destroy the ozone layers, no. Kaya yun, naging uso yung skin cancer dati dahil dyan, no? So, yan. Pero now, the nature is healing. Although, I just recently read a paper indicating that the ozone layer is getting bigger again. Kasi ako, when I was in high school, alam ko yun na yung pinakamaliit na size niya, no? Around 2010, no? So, maliit na daw yung size nun. Pero just recently, a recent publication by NASA states the otherwise. The ozone layer is getting bigger again. I don't know what the future holds for us, no. Ano na to? Survival of the fittest na lang talaga mangyayari sa atin, no. So ayun. So as another way to mitigate the bad effects of CFCs, we use alternatives, no, CFCs replacements, no. Kasi we know that CFCs destroy the ozone in our atmosphere. So as a result, gamit tayo ng alternatives, no? So the alternatives are the hydrofluorocarbons, HFCs, or the hydrochlorofluorocarbons, no? Ano yon? So mas onti yung chlorine and fluorine sa ating hydrocarbons, no? So mas onti na lang yung hydrogen and chlorine atoms doon. Okay? So as a result, no? So yon. Mas naging less yung destructive destructive effect nila sa ozone, no? So yan. So for example, we have here the CFCs used before. Ang kanyang global warming potential or the potential harm sa atmosphere ay 10,000 times, no? Pero starting na gumamit tayo ng mga HFCs or CFCs, no? Ayun, so bumaba na yung kanyang global warming potential. So bumaba na yung kanyang potential risk for our atmosphere, no? Ano pa? Sometimes meron ding refrigerators that use alkanes, no? Kasi napansin ko sa ref namin, sa chest freezer namin sa baba, ang ginagamit doon na refrigerant ay pentane. So hindi siya gumagamit ng chlorofluorocarbon kasi again, bawal na gumamit nito, no? Na napagkasunduan sa WHO na wag na gumamit nito because it destroys our environment, no? So yun, nagulat ako nung napansin ko yung ref nung binili yun dati. Nakalagay doon pentane, no? Sabi ko, wow, may alkane dito, no? So yun. So yun yung possible replacement for our refrigerants, no? With that ends our discussion for alkanes, no? Pero hindi pa tayo tapos. Babalikan natin yung halogenation. Tapos na tayo sa PowerPoint, no? So sagutan natin to. So, sabi natin kanina, our halogenation reactions are just substitution reactions. When we say substitution reaction, yung hydrogen ng iyong alkane will be replaced by a halogen. Ibig sabihin, yung isang hydrogen dyan, papalitan yan ng Cl. Yung isang hydrogen dyan, papalitan ng Cl. Yung isang hydrogen dito, papalitan ng Cl. Okay, so let's try to do this problem. Number 6, no? Name and draw the structural formulas for all possible monochlorination products that might be formed. May problema daw sa canvas. Ewan ko. Message lang sa amin. So anyway, so draw the possible monochlorination products that might be formed in each reaction. No? So basically, what we're going to do here is that we will replace hydrogen alkanes with Cl. Papalitan lang natin sila ng Cl. Okay? So, for letter A, ano gagawin natin? So, you have your hexane here. Palitan mo yung isang hydrogen dyan. Pwedeng dito, pwedeng dito, pwedeng doon, pwedeng dito, pwedeng doon, pwede dito. It doesn't matter. Basta magpalit ka ng isang H dyan, okay? Ng isang Cl. Okay? So, yan. And yung na-remove na H, no? That will be paired with the left Cl there, no? Kasi 'di ba dalawa yung Cl mo. Yung isa kakabit sa iyong alkanes, the other one will be alone, no? May malungkot siya. So kailangan yung H na kinuha mo kanina, i-partner mo siya doon sa iyong natirang Cl. Okay? So this is one of the monochlorination product of our cycloalkane, no? Cyclohexane. Basically, anong gagawin mo? Yung Cl, papalitan mo lang, yung H, papalitan mo lang ng Cl. Monochlorination yan, so ibig sabihin, one time lang yung pagpalit ng Cl. Sir, pwede po ba yung dichlorination? Pwede. Pero hindi ko na ipapagawa yon sa inyo. Ano po mangyayari kapag dichlorination? Basically, yung Cl2 mo, kakabit lang yan sa dalawang Cl. No? So, ganun lang mangyayari. So, pwedeng nandyan yung dalawang Cl mo, nandyan nakakabit. Pwedeng dito, isomer yan. Pwedeng dito din, another isomer yan. Pero hindi ko nagagawin yan sa inyo. Monochlorination lang tayo. Okay, so ano pangalan niya? So, pangalan niya ay si Gemerlin, hindi, no. So, ang substituent natin ay chlorine. So, anong pangalan ng chlorine kapag siya ay substituent? We give it the name chloro. Chloro yung pangalan niyan, no. So, ang pangalan nito ay chlorocyclohexane. Okay, isa lang yung substituent, so it is not necessary for us to assign a number. So, chlorocyclohexane yan, no. So, yan, plus HCl, hydrochloric acid. How about this one? We have here 1, 2, 3, 4, 5, 6 hexane plus chlorine. Okay, so ano kaya yung monochlorination product dyan? For this one, medyo maraming products tayo na pwede mabuo, no? Bakit po maraming products na pwede mabuo? Kasi maraming possible hydrogen siyang pwedeng palitan. Pwede yung Cl kumabit sa dulo. So we will have this product. Pwedeng dito siya sa carbon na to kumabit or dito. Okay? And yun lang yung mga possible plus HCl. Okay. So ito yung ating mga molecules. No? The Cl can attach to the end of the molecule sa CH3 sa dulo. Pwede siya kumabit dito sa carbon na to on the second carbon. So andun yung Cl. Pwede rin sa third carbon here. Sir, kunwari itong Cl ilagay ko dito. Same lang yun as this one. Okay? So if I place my Cl here, that's the same as drawing this molecule. Bakit, no? Kunin mo yung pangalan niyan, no? So kunin natin yung pangalan nila. So ito, anong pangalan niyan? Now, let's assign number for our substituent. Left to right, right to left, no? Okay, so yan yung mga numbers natin. So, nasan yung substituent natin? Either nasa 6 or nasa 1 carbon. So, ano yung pipiliin natin na substituent number? Di yung 1. So, that will be 1 chloro hexane. Hexane is our parent chain. The substituent is located on the first carbon. So, 1 chlorohexane yan. How about this one sa baba? Now, mag-assign tayo ng numbers. So, this substituent can either have a number 5 or 2. Ano pipiliin natin? edi yung 2. Okay? So, yung 2 pipiliin natin. So, I will name this as 2-chlorohexane. About this one, number 1, 2, 3, 4, 5, 6. Ay, mali. 1, 2, 3, 4, 5, 6. Okay. So, for example, dito naman sa molecule sa baba, ano yung magiging substituent number ng chlorine? Instead of 4, pipiliin natin yung 3. So, ang pangalan niya ay 3-chlorohexane. May sakit yung pusa ko. Okay, so 1-chlorohexane, 2-chlorohexane, 3-chlorohexane. Ilagay ko yung Cl dito. Okay, imagine nyo, kapag andito yung Cl, anong substituent number yung pipiliin mo? 3 or yung 4? E di syempre yung 3. So, same lang din yan ang pangalan, no? Sir, kapag dito yung substituent, ano yung number mo? 5 or 2? E di syempre yung 2. So, ito lang din yon. Sir, what if andito yung substituent? Ano number niyan? 1 or 6? E di syempre, 1 yon. So, yun din yun, no? So, yan. So, yan yung ating pangalan ng mga molecule, no? Plus HCl. So, always keep in mind, no? Kung pag flinip mo yung molecule, ibang name ba niya or same pa rin, no? So, these are the isomers of our chlorination products, no? Plus HCl. Huwag niyo kalimutan yung HCl. Let's have the last one para makakain na tayo. Dahil ako'y nagugutom na rin. Okay, so we have the monochlorination reaction of this molecule reacted with heat. Okay. So, saan tayo pwede kumuha ng hydrogens? Pwede kunan natin na hydrogens itong mga nasa dulo. Ito. Pwede mo hilahan yan ng hydrogens. Ito at ayon, pwede rin hilahan ng hydrogens, no? So, ano yung mga pwedeng products natin dyan? So, draw ko lang, ha? Okay, so ito yung mga possible products natin. Pwede, yung Cl, i-replace niya yung hydrogen dito. Pwede rin dito. Same lang yan, no? Pag dito yon, that's the same as itong carbon na to, no? Okay, so pwede niya palitan yung hydrogen dyan or dito. So, isang drawing lang yung molecule magagawa natin. So, dito kakabit yung Cl. Saan pa pwede kumabit yung Cl? Pwedeng sa dulo-dulo ng chain na to. Ito yung longest chain natin, no? So, pwede dyan, sa dulo. Pwedeng andito siya sa dulo. Pwedeng andito rin dito sa itong dulo na to, no? Pwedeng dyan din. So, I will not draw that, no? Itong nandito na lang sa kabila. Same lang yan. Ano pa yung pwede? Dito or dito. Pwedeng nandyan yung kabit. Pwedeng andito yung kabit, no? Sige. O, dito na lang. So, pwede ko rin yan ilagay dito, no? Pero that's the same as placing your Cl there. Oopsie. Ay, hindi pala. Bakit, no? Kasi tignan nyo, ito yung longest chain dyan, kasama yung Cl. Pag dito mo naman kinabit yung Cl mo, that's the same as this one lang din, no? So, ito pa rin yung longest chain mo. Same molecule lang pala tong nasa taas at baba. So, yan lang. Ito lang yung mga pwede natin palang maging product, no? So, the Cl can replace one of these terminal CH3s. It can also replace the CH here in the middle, no? So, we have two products plus the HCl. Pangalanan natin sila. So, let's assign numbers. Okay. So when assigning numbers na may chlorine na substituent, so siya yung bibigyan mo ng first number. So yung Cl yung bibigyan mo ng first number, edi Cl, edi 1 na. So we will follow the black numbering, no? So ang magiging name niyan ay 1-chloro, tapos may 2,3-dimethyl. Kano? So yan. So its name will be 1-chloro 2,3-dimethyl butane. Okay? So nasa first carbon yung chlorine, 1-chloro yon. Sa 2 and 3, meron kang dimethyl. And ang longest chain mo ay 4 carbons. So that's butane. 1-chloro 2,3-dimethyl butane. Anyway, sa ano naman, sa quiz, baka hindi naman siguro ako magbigay ng naming na ganito. No? Pinapangalanan ko lang para alam nyo kung ano yung mangyayari. Just in case na tanongin. No? Pero kahit di na, okay na. No? So yan. So the name is 1-chloro 2,3-dimethyl butane. Hindi yan pwede maging 4-chloro 2,3-dimethyl butane. Mataas yung combination eh. Always the lowest combination. Always. Always na nga. Always pa ulit. Okay. So yan. So that's the name of this compound. Ano kaya yung name ng compound na to? O, numbering. Okay. So mapapansin natin, ang combination kapag green ang gagamitin, 2 sa methyl, 3 sa methyl, 3 sa chloro. 2, 3, 3 yung combination. Pag black yung gagamitin, 2 sa methyl, 2 sa chlorine, 3 sa methyl. So ano yung better? The green or the black one? Of course, yung black one. Kasi ang combination sa black ay 2, 2, 3. Sa green ay 2, 3, 3. So ano yung mas lowest sa dalawang combination? Yung black. So masusundin natin yung black na arrangement. Okay, so let's name this compound. So sa 2 tayo. 2-chloro. 2-chloro, 2,3-dimethyl butane. Walang spaces. Yan. Okay, so the name of this compound is 2-chloro 2,3-dimethyl butane. Yan. Yung pangalan. Ganun lang. Hindi ko na gagawing complex yung naming kasi pare-parehas tayong gusto na matapos yung semester. Lapit na magpasko. Siyempre gusto natin okay na yung Pasko natin, wala na tayong isipin, kaya yon. Dadalian ko na lang po yung ating mga quizzes na, especially for the reactions, super dali na lang. As in ganyan ang gagawin niyo. Okay? So we're done na. So tapos na tayo sa alkanes. For the next meeting, I want you to read in advance yung ating alkenes and alkynes. So pakita natin 'yon. Ito. So next meeting, we will discuss the alkenes and the alkynes, the last two simplest hydrocarbons. So ano to, 31 slides lang. Medyo mabilis lang magiging discussion natin dito since we are able to cover alkanes na in general. So basically, yung mga lessons na makukuha natin dito sa alkanes, i-apply na lang natin sa other hydrocarbon. So mas magiging mabilis na yung ating lesson in the future. No? Okay, so we will continue our discussion on alkenes and alkynes on Friday. Please read in advance na lang. No? Be familiar. Kasi kung ano yung lesson natin sa alkanes, ganun din yung lesson dito. No? May onting dagdag na info lang. Okay, so yun lang. So that's all for today. I will see you again on Friday. With regards to next week classes, I don't still know if meron or wala because of the petition made by the Central Student Org. No? So if that is granted, pahinga tayo next week. Kapag hindi, magkaklase tayo next week, no? So anyway, so sa mga absent yung classmate due to the disruptions made by the typhoon, please let them know na lang na we continued our classes and the recording is as always nasa YouTube na. So yun. So I'll see you again next time, no? Next Friday. So yun. So stay safe and God bless, no? So ingat parate, no? So yun lang and bye-bye.